Okay, now members, we are going to see a new topic. This one is a topic that deals with relations, functions, and mappings. Let us go through, and these are very easy questions to handle if you're interested in getting very, very good marks. Okay, let us go through the definitions and we see. Let us start with the relation. Is defined as a phrase that indicates connection between a single set or two sets. A single set or two sets. Again, two is a factor of. These words like phrases, a factor of, a multiple of, cube of. These are words or phrases that are describing a relation between two sets or one set. Then mapping is a diagrammatic representation of a given relation. Mapping is denoted by an arrow like this. So whenever I say this one, it's a mapping. Then consider sets A and B, where set A is this, then B is this. Draw arrow diagram to illustrate that a set B is a square of set A. Now the one to show that these two sets are related in that set B is a square of set A. Now, you see that when I draw A here and I draw B here, you see that when I map 1 to 1, you see, when I square 1, I get 1. When I square 2, I get 4. When I square 3, I get 9. So this one means that the relation between set A and B is the word a square of. As simple as that. Because we square this to get these ones. Now, what this one is called the domain or the input. What we put in to get this. And then what we get is what we call the range or what you get after putting in a certain value. So let's see some examples here. Find the range corresponding to the domain. Now this is the domain. What we do, we just draw these two like the way you see them. Then they are giving us the mapping. We are going to use mapping x to this. So this x is what we call the domain, and this one now will become the range. So our domain is x. Now the mapping we are using is 3x plus 1. So indicate 3x plus 1. Now it's going to give me that. Now you write the elements in the domain like this. These ones. Then 3. You write them like this. Now what you do, you are substituting in this function here, in this, so that you get there. So now it's that x is negative 2. So when I put here negative 2, I'll be having 3 into negative 2, then plus a 1. This is negative 6 plus 1, which will give me a negative 5. So meaning, this one is going to be negative 5. Then when I come to negative 1, now such x is going to be negative 1. Now you substitute here x. So it will be 3 into negative 1 plus 1, which will be, this is negative 3 plus 1, which will be a negative 2. So you get the answer there. So that this one has been mapped to that. Then a 0, when I put here 0, so that will be adding 1. 0 and 3, 0 plus 1. When I put in 1 here, so that I'll be having a 4. It's mapped to that. It's mapped to that. This is mapped to 1. Then I put in a 3, I'll be having 3 into 3. Now x is a 3. So I put 3 here, then plus 1. This will give me 9 plus 1, which will be a 10. So here I show that this 3 has been mapped now to 10. As simple as that. So that's how we interpret the arrow diagrams. Now let us see some extra questions. Use a mapping. Now they are giving us their mapping x using this to complete the theorem below. Now they are giving us that when they put in negative 1, they get negative 7. Now for us we are going to get what we get when we put in these values. The same idea. So when I have 1, so I'll be having 4. When x is 1, this is my x. When x is 1, I'll be having 4 into 1 minus 3, which will be 4 minus 3, which is a 1. So meaning that the missing space here is for 1. So this one has been mapped to a 1. Then I come to when x is 2. when x is 2, what do I get? I get now 4 into, now we are putting here 2 minus 3, which will be 8 minus 3, which gives me a 5. So it shows me that now this one will be mapped to a 5, like this. Now in the next part, they are giving me the range. How do I get now this value? What you do, now this mapping will be giving you this. So it means that there, you just get the mapping you are using, you click this and you get the value of x. Now with this value of x, we have this. So what you do, you get the mapping you are using, then you put the value you got there. Then you get the value of x. Take this side. So be having 4x when the cos of the cosine becomes the plus. So be having now 13 plus 3. So your 4x will be now 16. Divide through by 4, your x will be a 4. So meaning the corresponding value for this that mapped. So it's a 4 that mapped to 13. As simple as that. Now when x is 6, we are putting here 6. 6 times 4, that's 24, minus 3, that's 21. So that mapping is done also. Then you come for this one of 29. Now so they are giving us this. All we do, we get now this to this. So minus 4x minus 3 is equal to 29. Take this side, 4x will be now 29 plus 3, which will be 32. So your 4x will be 32. Divide by 4, your x will be 8. So meaning 8 is what they use to get 29. So when they give you the domain, the range, you just equate the function you are using to map to that range. Then it's look for the value of x or y or n, and you get the value they use. As simple as that. Now here, they are giving us that, open the table below, they are giving us x, they are giving us that this map to this. Let us see. Now they are giving us, when we put here 0, so when I put here 0, I'll be having 0, and we put 0 minus 1, I'll be having negative 1. Now they are asking me, what about when x is negative 2? So when x is negative 2, I put it here. I'll be having now 2 into negative 2 squared minus 1. So when you are squaring this, you be careful. When you are putting it, when we square anything, we get a positive. So this will be 2 now times a 4. When we square this, we get a 4, then minus 1. When we multiply, we get 8 minus 1, which will be a 7. 8 minus 1, which will be 7. So our value here is 7. Now they are giving us 7 here. What is the corresponding value? So now we use now they are giving us this value. Whenever they give us this value, we just equate that. So now if I equate that, I'll be having 2x squared minus 1 equaling to 7. Take this side, be having 2x squared equaling 2. When I take it, it will be now positive. So I'll be having now 8. So divide through by 2, you have 4. Now to get this, I get a square root. So my x squared, get the square root of this, also the square root of 4. So my x will be plus or minus 2. And this is that we have already our, so I take a positive here. It shows me that this map to that, and also this map to that. Okay, when I come now here, they are giving me the value of x as 3. So if they do that, so you see that x here is 3. So when my x is 3, what happens? We substitute here. I'll be having 2 into 3 squared minus 1. This will be 2 times 9 in the square 3. Then this one, we first multiply, then we subtract using body mass. We always first multiply, then we subtract. Okay, so this will be now 18 minus 1, which will be 17. So here, means that this value is mapping this to 17. Okay, now they are giving us the range within the domain. What you do, you come and equate this to this. So there we are having 2x squared minus 1 equaling 2 or 9. So take this side, I have 2x squared equaling 49 plus, when this one comes, this side becomes 1, which will be defeated. So divide by 2. my x squared becomes 25. Get a square of both sides. So x is going to be plus or minus 5. Then we take a positive because we said they are increasing. Okay, this is plus, minus. Then here I have 97, so I need this. We just get this. Equate now to this. 97. Taking this side, we have 2x squared equal to 98. Divided by 2, by 2, by 2. Our x squared will be 49. Get a square of both sides. 49, and so my x will be plus or minus 7. And you see that we take the positive y because that our domain is it's going on from here, it's increasing. That's why I'm taking 7 like that. So it shows that this 5 map this to this, and then this map this to this. So that's how we handle that, members. I wish you well. We are going now to see happy grams.